Good evening, everybody. This is AUC Modeling. Right now, we're discussing the modeling age for our group, for our data analytics project. Starting off, we can go ahead and meet the team.
My name is Dexter Hiding. I'm a senior accounting major from Atlanta, Georgia.
My name is Austin Carter, a senior business management major from Atlanta, Georgia.
My name is Jay Sean Kent. I'm a junior business administration major, finance concentration from Atlanta, Georgia.
My name is Joseph D.E.D. Jr. I'm a junior finance major from Springfield, Massachusetts.
All right, kick it out to explain who we are to the group. So we were hired as a research company. Topic was to present to directors and clients and investors with small business owners. So right now we're trying to find a modeling age. We have 50 people randomly selected from a shopping mall. Each person in the sample is shown a typical cigarette advertisement and is asked to estimate the age of the model in the ad. So through 50 perceived age estimates obtained, we use the L exercises through 2.78 and 2.81 through the book, based determine the best model in the age. Model ages all have to equal or have to be more than 25 per guidelines.
As we can see in the dot plot, we have most of the ages in between 15 and 30, but the youngest age that people think is 17, and oldest is around 31, 32.
So for the percent frequency histogram, as you can see, the peak is centered around the age of 25 to 29, which basically tells us that this age group has received the highest number of age estimates. The distribution is slightly skewed to the right, as there are a couple older age estimates in the 29 to 32 range as well.
All right, so regarding the frequency chart, so basically the chart's put down to 6 different groups along ages range from 17 to 34. The age range is around 2 years difference for each group. So first group, age 17 to 19, show about 4 people, but the first two groups show 4 people. The biggest group was the 26 to 28 age group that showed about 20 people on there out of the total 50, so it had the highest percentage wise. For frequency distribution, 8% for both 17 through 22 was seen as that low age. 16% was seen as 23 through 25. 40% was seen as 26 to 28. Yeah. 2.4%, sorry, 0.24% was seen for between 29 and 34. So when it comes over to frequency distribution, it breaks down to 8%, 16, 40%, 2.4, 2.4%. And then a cumulative frequency distribution, yes, breaks down to how you see over here. So we're showing really a high amount of people who are perceived above the age we need it to be. Because we needed at least 60% people above the age of 25, or at least we perceived above that age, and we've hit more than that amount we needed.
So now we'll look at the OJIVE chart to create the percent frequency OJIVE chart. I plotted the cumulative percent frequencies on the y-axis and the upper class limits, which were 20, 23, 26, 29, and 32 on the x-axis in Excel. The number of perceived age estimates that are 28 or less is the cumulative frequency for the 27 to 29 age group, which is 52. And the percentage of perceived age estimates that are 22 or less is the cumulative percent frequency for 21 to 23 age group, which is 28.3%.
All right.
Now that we went over the part one, quick review, now we can get into part two and talk about our hypothesis test that we've created. And we're going to report all of our significant findings from the data and the different variables we found.
So first, we looked at the hypothesis testing. Since we have a sample mean and standard deviation, we use the t-distribution. This test would be the sample mean minus the hypothesized mean divided by the sample standard deviation divided by the square root of the sample size, which in this case would be 23.663 minus 25 divided by 0.508551, which gave us negative 2.629. And we needed to find the degrees of freedom to get our critical value, which was 50 minus 1, the sample size minus 1. And we can reject the null hypothesis at 0.001 level of significance, but not at the 0.01 level. So we have strong evidence that the industry requirement is not being met, as we are able to reject the null hypothesis. And this is important. If there are consequences of not meeting the industry requirement, such as fines or losses or reputation, this could result in it being practically important.
So for the confidence interval, so we're asked by 95% confidence interval for cigarette viewer age, which is 27 point, basically around the age of 27 is what most people think they are, like 27 and a half years old. The industry requires that the model look at least 25 years old. And then since 95% confidence shows that, models are at least 25, we have met standards. We've kind of sort of exceeded standards by a good 2 years. So we're doing pretty good so far. The mean perceived age is greater than 25. The raw calculation will tell that 95% constant intervals are models look between ages of 25 and 27. So we took the standard deviation times the z-plot times the number we're given divided by the square root of the model age we had. That came out to plus and or minus. So on the high side, we have 27 years of age. On the low side, we have 25 years of age.
So here we have our hypothesis testing continued. Rejection of the null hypothesis at different significance levels. For the first alpha being at 0.1, since the p-value is 0.0057 is less than 0.1, we would reject the null hypothesis at a 0.1 significance level. Alpha at 0.05, since the p-value is also less than 0.05, we would also reject the null hypothesis at a 0.05 significance level as well. And for the 0.01 alpha, the p-value is also less than 0.01, so we would reject the null hypothesis once again at the significance level. It's greater than 0.001 in this case, so we would not reject at that significance level. By describing the evidence that the industry requirement is not met based on the p-value and the significance levels tested at 0.1, we have a strong evidence to reject the null hypothesis, suggesting that the industry requirement is not being met. And at alpha 0.05, we also have strong evidence to reject the null hypothesis, further indicating the industry requirement is not being met.
Well, that's the hypothesis testing and the confidence interval information that we've gathered. And in a couple of weeks, we will be back and talk about the model that we'll create, and we'll talk about our results and show you why the model proves our test hypothesis in our research question.
All right. Thank you for your time.